tomorrow will be better. A man applies a 50 Newton force on a 20 cm long doorknob. Where on the knob should the force be applied for maximum impact? The first thing here is that I wish to remind you that we apply forces on doorknobs to create or to bring about a rotatory effect, to bring about rotation. So when they're asking for maximum impact, it means where exactly on that knob should that force be applied for us to have maximum rotation. Follow me, dear friends. Solution. We're talking about the moment of a force here. So let's start by reminding ourselves the formula for moment. We know that the moment of a force, M, is given by the magnitude of that force times what we call here the lever arm, which is the distance between the axis of rotation to the point on which the force is applied. It has to be a perpendicular distance. We have to lay some emphasis on it. So if you've understood this, let's draft a little bit of what's happening. Let's draft a sketch. Let's sketch what's happening. This is the axis of rotation and the force has to be applied somewhere along here. All of this length is 20 cm. Clearly, according to this formula, the greater the distance away from the axis of rotation, the greater the moment we are going to have. So, for maximum impact, as the question clearly outlines, it will be beneficial for this force to be applied at this free end of the knot here, which is 20 cm away. And if we do this, what is the moment we're going to obtain? This means that the moment will be the magnitude of the force, which is 50 Newton, times, here you have to be watchful. The distance here is given in cm. We have to change it to meters. So, times 20 divided by 100. This is how to convert from centimeters to meters. And if you correctly punch this, you will have that the moment will be 10 Newton meter. This is the greatest, or this is the biggest moment we can obtain from this setting if we apply this force at this free end of the knot. Tomorrow will be better.